Hi, hello, vanakkam, and welcome back to yet another episode on your favorite Little Slaw YouTube channel. So today in this video, we're going to see about one of the most powerful debugging and profiling tool, and it is primarily used for detecting memory errors and for any leaks in programs, particularly which are written in C, C++, and in fact, in most of the applications, you can use Valgrind. Yeah, so we're going to see about Valgrind, the tool called Valgrind. So we're going to see how to use the memory leaks, how to use the cache issues and everything using Valgrind tool. And uh, I haven't found any materials for this, so I think we are the first channel who is going to discuss about this, and who are going to like in real time, in practical real time, we're going to discuss about it. So thank you so much for watching this video, and please don't forget to subscribe to our Little Slaw YouTube channel if you haven't subscribed it yet. And thank you so much for following us. And if you or any of your friends are facing any issues in terms of performance testing, performance engineering related topics, please do refer them our channel for them to get into it. So firstly, let me give you a quick introduction before we move on to this tool. So this Valgrind tool, as I told you, it's very powerful and it's mostly a profiling tool. So how it works? So it works by tracking the memory usage and by identifying the issues like uninitialized memory, freed memory access, and out of bound access as well. And just to give you a quick introduction about memory error detection, so this Valgrind Memcheck tool has its core features, and its core feature is to detect any memory errors like leaks, like invalid memory accesses, and checking for any use of uninitialized memory. And even it is used for profiling. So we all talk about profiling. So Valgrind provides tools for profiling. It allows us to analyze a program's performance and identify areas for optimization. And it supports Linux, Solaris, Android, FreeBSD, and macOS as well. Again, Valgrind is a freely available under the public license, so you can use anyone can use this Valgrind Memcheck tool. And now let's go on to the video. Let me quickly log in, and then we'll use this Valgrind commands to see how does it really work. So now I have logged into my system. I have logged into my Linux terminal, and I'm going to use the command, which is the so now I have changed my directory to the scripts folder, and I'm going to paste the command. And here I have used the command, the Valgrind tool. So I'm going to do a memory check. Yes, that's the first operation which you're going to do. So the first operation is going to be memory check using the Valgrind tool. And I'm going to check for any memory leaks. So I have enabled the leak check is equal to S. And then I will reach to all possible functions and parameters, like whatever is possible to reach, I'm going to do it. And then the number of calls, I'm limiting it to 20, and I'm going to track for the any file descriptor section. And finally, I'm going to test my EVOLK application, and when I click on enter, here you can see Memcheck, which is a memory error detector. And I have opened file descriptors. It's showing like I have opened 3 files. So like heap memory, which is in use at 35 bytes in 2 blocks, and the total heap usage is around 3 allocations, 1 free and 47 bytes allowed. And here you can see there is like 16 bytes in 1 block, which are definitely lost in lost record. So this is how the memory check tool tells you, like for example, out of 16 bytes in 1 blocks, I have lost few memory, and then in even 19 bytes in 1 blocks are definitely lost in lost record of 2 of 2. And this is the one thing which you might have studied, like the malloc, calloc things, right? So this is how it works. So this is what it is supposed to be there in the system. And here you can see out of 35 bytes, like we have got 35 bytes in 2 blocks has been definitely lost. So this is how the memcheck tool tells you. And now you get to know, okay, there are some issues. And here even in the error summary it tells you that there are 2 errors from 2 contexts, right? So the same way, this memcheck tool gives us the description, exact description of what is happening. Then the next part is we have to tell the same, we have to give the same uh, uh, allocations, the same results to the developers, and tell them that, see, I have found issues in here. Like for example, in the main, like under the home cloud user scripts, I've got some issues. So we're going to share this with the development team and ask them to fix this issue. So that is all about the Valgrind Memcheck tool. And this shows that there is a loss, and there is definitely a memory leak check has to happen. And now we'll move on to the second operation. So let me quickly clear it, and let me run another command. I'll explain it to you clearly. So here again, we have used the same command, the Valgrind Memcheck. The leak check is yes. I'm going to show the reachable yes. The number of calls is going to be 20, and the file descriptors is equal to s. The log file, I'm going to, so the command that has been added, that changes between the previous one and this one is, I'm going to check a different application. Previously it was evolk application, now it is evo error application. And I'm going to add a log file because we need to get the log file, right, to share with the development team or whatever the team we are working with. So when I click on enter, the file has created. So we don't see that in the direct output. Instead, since we have sent all those logs into this file here, and now let's read it. And to read the file, yes, we know the command, that is less. So if I type less, here you can see it is asking me the file name. So let me enter less space the file name here that we have created. It is the evoer.log, sorry, less paste. Oh, come on, let me type it. So less space evoer.log. And now this has given me what are all the issues. And here you can very well see there is an invalid write of size 4, and there is an issue of, again, the malloc issue. There are some issues again with 4 open 3 std exit, and okay, again in the heap summary. So here you can see we've got 1 allocs and 4 to 40 bytes allocated. So let me explain clearly. So what happened? So our program wrote 4 bytes past the end of the heap allocated memory block. So where it happened is, so the error has occurred in function f. Here you can see at address. This here is the address, and the memory was allocated using malloc. So we have got, we allocated 40 bytes of memory using malloc. So what happened is there was an invalid write that happened exactly at the byte after the allocated block, that is 0 bytes after a block of size 40. So that's what we are seeing here. So 0 bytes after a block of size 40, including indicating a classic buffer overflow. So this is what we normally call it as the buffer overflow. So that was happened during this scenario. And then the next one is, since we have allocated 40 bytes of heap memory and never freed it, the impact is definitely a memory leak, as we have found it through Valgrind. And then the file descriptors, where we can see 4 open, 3 std exit. So what happened here is the file descriptor 3, that is using the log that we have seen, was still open at the exit. So it is still open, right? It has not been closed. And what happened is, while this is not a critical issue, consistently failing to close the file descriptors can lead to resource exhaustion in long running applications. That's the reason we could see the resources were getting overutilized, or like there is no resources to be utilized. So it is because these file descriptors were still open even after we exit the program. And then so some of the recommendations that we can recommend it to the developers is, like, we have to ensure that we don't write any we don't write past the allocated size in malloc. So if we allocate 40 bytes, limit access to indices like 0 to 39, so that there won't be any issues in terms of the allocated the malloc sizes. And we can add a free of call to for the pointer returned by malloc once we are done using it, and make sure we are closing the opened file. So we have to explicitly use fclose any file streams or close off function for any file descriptors our program is opening. So that's how we can fix all these issues. So like I told you, just a quick summary. So we have told that we have got 2 errors from 2 contexts. So the one is, the first thing is the memory was allocated using malloc, which is around 40 bytes. So what happened is there was an invalid write that happened exactly at the byte after the allocated block. That is the first issue. That is, so because of that, we have allocated 0 bytes after a block of size 40, which indicates a buffer overflow. And the second thing is the closing. So the file descriptor 3, the evoerr.log was still open at program exit. Right. So these are the two errors. These are the two issues which we found using this memory check error. And now the third one is we're going to try using the Valgrind cache. So we'll see how does it work, and it's going to be more interesting. So now here the third one, that is Valgrind tool. So previously we used Memcheck, and here we're using cache grind. So this is very simple. We only need to identify the tool and mark data to the file. We are marking the data to the file, that is evoke.out, and we are testing the application, that is evoke. And let me click on enter. Yeah, so now we got it, and we click ls. So here what happened is, so we are reviewing the file, that is the evoke.out file. So let me do again less to open the file, evoke.out. So here you could see, yeah, I can understand that it's going to be new, and it'll be like quite difficult, but let me explain it to you real quick. And again, the main thing that we are going to use this cache grind. So we all know CPU in our system, which is like a chef who store the ingredients, which is the data and instructions close by in caches. So if we can't find what we need, they will then go to the bigger memory, that is the RAM, so which takes longer, right? So instead of having things instead of the cache, if we don't find the items in the cache, what it will do is it will go to the RAM. So cache grind tells us how often this happens. So the very first thing, if you see here, the first refs, the misses and the LLI misses. So what happens is the CPU that we are running now has nearly fetched 789 million instructions, and only 1712 missed the L1 instruction cache, and even fewer missed the last level cache, that is around 1624. So what happens is our instruction cache rate is excellent, which is like 100%. And the next part is the derefs. So here you can see the derefs, which is around 360 million, and then the D misses is around 20,000, and the LLD misses is around 10,000. So what happens is our program accessed 361 million times, and only 21k missed the L1D cache, L1D cache, and half of those missed the last level cache. So this is the last level cache, the LLD cache. So what happens is, again, this is very good. Our data is staying in fast access memory most of the time. So the summary of the cache efficiency is the LL miss rate. That's the one that you're seeing here. The LL miss rate is around 22,572, and the LL misses is around 12,091. So the LL miss rate is close to 0%, which means our code is very cache friendly, and it is accessing data in a way that makes the full use of our CPU's caching system. But why this is matter? Why should we do this? Why should we even check this? Because even without changing our code logic, we can improve the performance by writing the cache efficient code. Like we can use arrays instead of linked list, or we can access the memory sequentially. So that's the way we can improve the performance. So the final tip is, always we have to use cache grind and memcheck, because the first one fix the memory bugs with memcheck, and the cache grind to fine tune the code speed. So this one you can explain it to the developers and tell them that this is what is happening, and this is what is the number that has been missing. So if you want to learn more about the cache grind, the Valgrind Memcheck and cache grind, please do reach out to me, and don't forget to subscribe to Little's Law YouTube channel. Take care, and bye bye.